Hi, Sapora here, marine biology. Okay, for this first assignment, it's a big one. It takes a couple weeks for you to get done. Is going to be our oceans map. So you have a blank map here. And on here, we've got all the different oceans of the world. There's actually 5 major oceans, and you could divide a couple of those in half by north and south. And then you've got all these little seas and straits and other pieces of ocean geography that you need to learn to be familiar with where is what on planet Earth when it comes to the ocean. So for this one, I have a list on the back side of the handout, which you'll see there and here. That lists what I want you to draw on here and include on this map. So first off, we're going to put the major things like the equator and the Tropic of Capricorn, Cancer, and Arctic Circle. And then you're going to list the 4 major ocean basins and all of the little seas, straits, and bays. Oh, along with the continents. So I'm going to go over that now with you, step by step. In the end, the product that you have is going to be something that looks like this. This is a former student's work. So it has everything labeled and beautifully done. And it's hard to fit all of these different names in here. So this person put numbers and then created an answer key for that. So number 12 is the Mediterranean Sea. Okay. Another example of a student's work would be something like this. So here, they actually wrote the names on here of all of the different geographic features, oceanographic, I guess, features that I'd want you to learn. Taking this and turning it into this. That's what we're going to work on here today in this video. Okay. So you can use Google Earth. I highly recommend that to type in the names of these places in the search bar and find them, get familiar with them. In the end, you should be able to swing around and you would know that this is the Gulf of California, this is the Gulf of Mexico, the Caribbean, this is the Bering Sea, the Chukchi Sea up in here, this is the Bering Strait, on and on, etc., etc. We'll go over these right now in this video for you. Okay, first thing I want you to do is take this piece of paper right here and I want you to put a ruler on where you think the equator is, the equator on this piece of paper. Okay. Look around the class, look at someone else's and see where they put the equator and see if it's in the same spot, a similar spot. See if you are close to what they are putting down. And then let's see if we're correct. So the equator, most people on this map would put it somewhere up going through Mexico because it tends to be where we think land falls. Whoops, switch over to here. You want to put it right through the middle here, maybe hit the Hawaiian Islands. And it turns out it's further south on this map than you would think necessarily. A lot of maps are what we call geocentric or sort of Earth-centric, terra-centric, land-centric, putting land in the middle. So it shifts everything a little further, shifts the north down to the south on here. The equator on this map is going to be a line that runs right through a particularly cool chain of islands, 600 miles off the coast of South America. And these are the islands that Darwin visited on his journey around the world. And they are the Galapagos Islands right here off the coast of Ecuador, right here. So usually the Galapagos are a little dot you see off the coast of Ecuador, and they sit right on the equator. So you draw your line going right across here. It would run right through the Amazon basin, which is the world's largest rainforest, right on the equator. Then it cuts right through Africa, right below the big horn right here, right through the middle in the Congo basin, and then slices right through Indonesia, through the island of Sumatra, through Borneo, and right there. When you look at it on Google Earth, it kind of makes sense. Right here is the Galapagos, cutting right through Ecuador, the darkest, greenest place on Earth, the Amazon basin right here, where it rains all the time. That's the equator. Follow the line of clouds across, because it's always raining there, through the Congo basin. And then continue around through the Indonesian rainforest. This is the island of Sumatra, and this is Borneo, the rainiest place on Earth. That is the equator. So draw that on your map, that line, and label it. Label it as equator, 0 degrees. Okay, it's just right in the middle. So I put links here as well, and you can click on that, and you'll see a line right here. Click on that. Where's the line? This is line to me. Lining. Okay, oh, right here you can see the line right there, 0 degrees, and you can see where it cuts through. Exactly where I said. Good job, me. Okay, next up would be lines north and south of this. These are important geographic features. You'll hear them mentioned or see them mentioned quite often in reference to places. So the Tropic of Cancer and the Tropic of Capricorn. The Tropic of Cancer is a line that runs through 23.5 degrees north of the equator. It's actually 23.26, whatever. And so draw that line right here. It's going to go right through the southern tip of Baja, right through Mexico, cutting through the Sahara Desert and the Arabian Peninsula, right across India, and then southern China in here. That is the Tropic of Cancer. What makes the Tropic of Cancer unique? Well, 23.5 degrees happens to be the tilt of the Earth, and so north and south of this, depending on the seasons, this has an influence on weather and climate. And there's a permanent weather feature that you see at this line, at this 23.5 degree line, both north and south. That permanent weather feature is the air rises up at the equator. Air is rising up here, and then it falls and descends here along this line. And as it rises, it picks up lots of condensation, and it rains, and all the water comes out of it. And then as the air moves north and south and then descends at 23.26 degrees, as it descends, that air that has already been completely dried out and rained out starts to expand and becomes even drier as it moves down. And it creates this belt of deserts that runs around the planet at 23.5 degrees. The Sahara Desert, of course, running right through the Tropic of Cancer in the north, and then continuing around here. It gets a little bit of rain here because of the monsoons. And then we have our own deserts here, right at 23.5 degrees as well in the United States, the Southwest deserts. Okay, so that is the Tropic of Cancer. On the bottom end, below the equator, is the Tropic of Capricorn, and the Tropic of Capricorn is also at 23.5 degrees, albeit to the south. So draw your line right here. So take your ruler, set it on your map, line it up here, across where you see it going. It goes right through the bottom half of Central America, cutting right through the top part of Chile, going through South Africa, touching the bottom part of Madagascar, and right through the heart of Australia. All of these are arid, dry regions as well. So you get your southern deserts, although there's not as much land in the southern hemisphere as there is in the northern hemisphere. So a lot of this is ocean habitat as well. So in the south, 23.5 degrees cuts right through this dry area in here. Cuts right through South Africa, right here, which is dry. And then the driest desert in the south, this Australia, which is basically one giant desert, ringed by some coastal habitat. That's some cool stuff going on there. All right. Those are your main lines. The equator, Tropic of Cancer, Tropic of Capricorn. Label each of those. Label them with their degrees, 0 degrees, 23 degrees, and 23 degrees north, 23 degrees south, Cancer. The next line you'll draw on your map would be the Arctic Circle to the north. The Arctic Circle is at 66.5 degrees. Now, if you add up 23.5 and 66.5, you get 90. Okay, so 23.5 is actually the tilt of the Earth. The Earth is tilted 23.5 degrees off its axis. And that tilt of the Earth means that part of the year the sun is shining here and hitting the southern hemisphere mainly, and not really hitting the northern hemisphere as much. This is winter in the north, summer in the south. When this is happening and the Earth is spinning on its axis here, facing this way, above 66.5 degrees, the Arctic Circle, at that winter point, you get full darkness for at least one day. You do not see the sun. That's because it's tilted 23.5 degrees. So subtract 23.5 from 90, and you get 66.5, that line right there, full shadow for part of the year. On the other end, when the Earth is facing the sun, right, and it's summertime here, that Arctic Circle is where you get full sunlight for at least part of the day, or for at least one whole day as well. So the Arctic Circle is at 66.5, and a little harder to draw because I gave you a circular, oh, here it is. Boom, right there. So going through upper Alaska, Canada, Greenland, touching the top of Iceland, cutting through northern Scandinavia here, and then right through Mother Russia. Make it, right, girl, make it. Okay. This would be 66.5 degrees, what you would label that as, and it would be the Arctic Circle. The Antarctic Circle is further south, cutting through Antarctica, and we don't have that on our map, so we can go ahead and skip that for now. You will also be labeling the continents on your map. So while I may take this for granted, I want you to label these. So the continents on your map: North America, South America, Africa, Europe and Asia, as far as biologists, geographers, scientists go, is really one continent called Eurasia, one word even. The Eurasian continent, the whole Europe and Asia division is something we can talk about in class. It's a line that people drew and kind of make believe. They know the Ural Mountains are right in here, but that's not enough. So Europe, Asia, or Eurasia, I'm fine with that. I think you should think about it that way anyway. Australia, New Zealand is not a continent, but it is a cool island, north and south right here. You can write NZ. And then up in here, this is part of North America. It's not as big as it shows here because it's been stretched out for the purposes of this. Better reference point would be to look at it here. There it is. That's just Greenland. That's part of North America, a big detached piece of rock that is covered in ice. Greenland and Antarctica are the two continents, or the two largest big places that are ice caps, not just glaciers, but ice, just sheet going down, covering mountain ranges itself. And in Greenland, the ice cap is 10,000 almost feet thick, or 2 miles thick. So just covering this. And again, Greenland and Antarctica are the two land masses on Earth currently covered in ice. Fun facts. Okay. Whew. Covered a lot there. Take a breath. Also to include on your map, the continents. I want you to color in each continent. I want on each continent a major mountain range, a major river, and a major desert, a major river drainage. So for instance, in the United States, you would put North America, you'd put North America, Southwest Desert in here. Major river, you could put the Columbia or the Mississippi. You could put the Yukon as well up here if you wanted. And a mountain range, probably the Rocky Mountains, the most notable, or the Appalachians, or the Sierra Madre or the Sierra Occidental, which run down through Mexico, which are really extensions of the Rockies, but also their own volcanic ranges. In South America, you might put the Andes Mountains here, the Atacama Desert, and the Amazon Basin. Okay. And on and on. So pick your own deserts, mountains. Of course, you've got the Sahara Desert and the Nile River here. And Asia has a plethora to choose from as well. And included in Asia would be, the Arabian Peninsula and the Middle Eastern Desert region is a part of that as well. Also the Gobi over in here. Australia as well. Okay. Now for the bodies of water, though, what we've all been waiting for. Boom, let's go. Okay, major ocean basins. Let's talk them. So the Pacific is the largest ocean basin on the planet. In fact, you can look at it as a North Pacific and a South Pacific, and I want you to label it that way on your map. So on your map over here, you're going to have North Pacific and South Pacific, North Pacific, South Pacific. This map puts the Atlantic in the middle. I prefer the Pacific, but North Pacific and South Pacific. It is divided by the equator. So the equator divides the North and South Pacific, and it's because the water masses in each particular basin, if you will, rotate different directions. And so while they kind of bump into each other, these are two different water masses, okay? This one rotating this way, and this one rotating this way. So different directions, and coming together at the equator, right in here, but not exactly fully mixing. So, and the currents generally running out along here, going from east to west, along with the major wind currents there. El Nino is when you get a reversal of this, and then we get a warm current up from here. Okay. So that's North Pacific and South Pacific. You can see that here on this Google Earth as well. The second biggest basin is the Atlantic Ocean. And again, the Atlantic can get divided by north and south, being split by the equator there. So North Atlantic and South Atlantic oceans. And the Mid-Atlantic Ridge is a giant zipper going down the middle of the Atlantic, separating North America from Europe, separating South America from Africa. And they've been pulled apart about 3,000 miles in the last 200 million years. But this was connected. The Pacific Ocean has never been closed geologically. Continents have moved around, but they've never gone all the way around the Pacific and then come back or anything like that. It's the world's oldest ocean basin, connecting back in time to what was called the Tethys Sea, which would have been the sea that kind of surrounded the planet when all the continents were joined in Pangaea and Gondwana land. North Atlantic, South Atlantic. Next major ocean basin is the Indian Ocean. The Indian Ocean sits in between Australia, Indonesia, India to the north, and then Africa on the west side of it. It is a large ocean basin with lots of different chains of islands, and you can actually see where India has slid across the ocean floor, been transported across the ocean floor, and then pushed up into Asia, colliding with it. See all the folded rock material here on each side of it, and then the crumpled mountain range called the Himalayas at the very end of it, where it's smashing into Eurasia. Indian Ocean. Okay. Other notable oceans in the south and on your map. Down in here, just right along the bottom, Southern Ocean. Southern Ocean down here. It's got a continual ocean current that is running left to right, so almost in a clockwise fashion, continually around the giant bulk of Antarctica. So it's got this constantly churning ocean current around it, kind of creating its own little ocean basin ecosystem down in here. All of the ocean's waters mix. It takes a drop of water 1,000 years to fall right here, travel around, go up through the Pacific, through the Atlantic, and kind of circulate everywhere. And that's an idealized model, but it works. Still, this is its own separate technical ocean basin down in here called the Southern Ocean. On the other end of things, flip it over to the North Pole right here. This is the Arctic Ocean. The Arctic Ocean right up here in the north. Okay, kids, we have the North and South Pacific, North Atlantic, South Atlantic, Indian Ocean, Arctic Ocean all along here. Again, it looks bigger, but it should be kind of compressed. And the Southern Ocean down in here. This is the Pacific as well. Those are the major ocean basins, and those are all, although all the water intermixes, this has its own special circulation system. The Pacific has its own special circulation system turning up in here. The South Pacific has its own circulation system. Same with the Atlantic, has its own circulation systems here and here in the South Atlantic, and then the Indian Ocean, again, has its own circulation systems as well. These bump up together, and there is some mixing, but these spin in what are called gyres, and we can talk about those later, sort of creating their own temperature regimes and regulating their own climates, weather patterns, and ecosystems. Okay. Within that, we've got a bunch of little tiny bodies of water, which are called seas and straits and things like that. And we're going to go over those now. Take a breath, stretch it out. Okay. Earth, equator, Tropic of Cancer, Tropic of Capricorn. Air rises, wet. Air falls, dry. Makes sense. Arctic Circle, dark most of the year or light most of the year up in here. Northern Hemisphere, mainly land. Southern Hemisphere, mainly water. Think about it. Kind of cool. Major ocean basins: North Pacific, South Pacific, North Atlantic, South Atlantic, Indian, Southern Sea, Arctic. Let's get to the small stuff. There are a whole bunch of tiny gulfs and seas and things like that that we're going to talk about now. These have their own little mini circulation systems within them, and also their own particular ecosystems and weather patterns as well. There's big weather patterns, and then there's small local weather patterns that surround the Earth. The Gulf of Alaska is one of those. We're going to jump. We're right here in Oregon. We're going to jump right up here to the Gulf of Alaska. This has its own special weather pattern. We get this weather pattern down here in the wintertime quite often, coming down to us as well, bringing lots of rain and things like that with it. That's pretty cool. And in the summertime, we'll even get some cool air from this as well. Gulf of Alaska, right in the little armpit here. Okay, going around the corner, we've got this chain of islands here that can almost connect, but there's about 1,500 islands that stem off the Alaska Peninsula over to Russia. This is the Aleutian Islands. Aleutian Islands, named after the Aleut peoples that live there. And this is a volcanic series of islands that go over here. I have worked on and spent many summers on these islands. I've worked on 5 summers on these islands, including the Pribilof Islands right up in here. For the Fish and Wildlife Service doing seabird research. Why I'm teaching a marine biology class? Because I got some experience. Okay. So up here, the Aleutian Islands separate the North Pacific from the Bering Sea. The Bering Sea right in here, named after the Russian explorer and sea captain Vitus Bering, who came through here 2 times and then died on the Commander Islands right here in the late 1700s. The Bering Sea is an important fishery. It's got a lot of shallow water right in here, and a lot of animal species depend on this and rely on this and migrate here during the summertime. North of the Bering Sea is the Bering Strait right in here. During the Ice Age, this was connected, and you got Diomede, little Diomede Islands here. Check these out. I've never been there, but I want to go. This little Diomede, isn't it? It's not going to reveal itself. I swear that's what it's called. Oh, maybe that's it right there. Big and little Diomede. Okay. This strait right in here is the Bering Strait, separating the Bering Sea from the Chukchi Sea right in here. As I'm going over these, be flipping these over and crossing them off here and checking your spellings. And if you're having a hard time, go to Google Earth and type in Chukchi Sea and find it for yourself. Be familiar with it. It's helpful to zoom out and kind of quiz yourself and then zoom back in, and the words will appear and you can see if you're right. Off the Chukchi Sea to the left is the East Siberian Sea. Over here, off of northern Russia and Siberia, a hugely important ecosystem for seabirds, whales, walruses, lots of marine organisms depending on this. Polar bears, big shallow, huge shallow shelf. Very productive ocean. To the right, over here, then, of the Chukchi Sea, so you got the East Siberian, the Chukchi, and the Arctic Ocean, right off Alaska. We call this the Beaufort Sea. That's right, Beaufort. Beaufort Sea, right there. Yeah. Okay, Beaufort Sea off Alaska, right there. And then, of course, all that's part of the Arctic Ocean here. If we want to travel to just a little bit to the west of the Bering Sea, this big peninsula right here is called the Kamchatka Peninsula. It is a hugely important ecosystem and reserve for wildlife off of Russia. It's got bears and eagles and salmon fisheries and volcanoes and just gorgeous rivers. Pretty amazing place, the Kamchatka Peninsula. And off the Kamchatka, separating it from Asia over in here, or mainland Russia and getting into China now, is the Sea of Okhotsk. Okhotsk. Sea of Okhotsk. Big shallow sea and a very important fishery as well. By fishery, I mean a body of water that contains tons of different fish species. Plankton, whales go there, marine mammals, seabirds, all kinds of things depend on these areas, not just humans, for their existence. Okay, let's just keep cruising around this way then. Below the Sea of Okhotsk is the Sea of Japan. The Sea of Japan sits in between Japan and Russia, North Korea, China, kind of interface right in here. Sea of Japan, right back in here. Sea of Japan on your map would be right in here. Here's the Sea of Japan. Here is the Sea of Okhotsk, or the Okhotsk Sea, Sea of Japan. Bering Sea, Bering Strait, Chukchi Sea, Beaufort Sea, East Siberian Sea, here over to here, Okhotsk Sea of Japan. Yellow Sea is next. So below the Sea of Japan is the Yellow Sea. The Yellow Sea sits in between the Korean Peninsula, consisting of North and South Korea, and then mainland China, northern China. Northwestern China? Right over in here. So the Yellow Sea right in here. Below that is the East China Sea right in here. Yellow Sea, East China Sea, and then the South China Sea. The South China Sea is a hugely important area, mainly just for shipping and things like that. And there's a lot of political tension constantly going on there. You can follow that on the news. Who is sending warships to what to protect boats moving through there? It's a commonly disputed shipping avenue for really global marketplaces. So much of what we buy is manufactured and then shipped through this area, right through here, and then out to the world. Okay, South China Sea, hugely important. Let's look at where that would be. South China Sea, right in here. Yellow Sea, East China Sea, South China Sea. Okay, below that, it gets, well, now we're into Indonesia. Indonesia is a big chain of islands, and politically it gets confusing down here in Southeast Asia because everybody's sliced and diced it up. The Philippines are really just a part of Indonesia. They're just this cluster of islands off to the northeast side of the Indonesian archipelago. And there's a huge subduction zone out in here. The Marianas Trench is further out, but there's a lot of volcanism and tectonic activity out in here, creating these islands. This is Indonesia, but this is Borneo, and Borneo is part of Indonesia, except for this part of Borneo is technically part of Malaysia. I'm not even joking. It's ridiculously confusing. New Guinea is not part of Indonesia, but obviously it is, or is it part of Australia? I'm not even kidding. All I need you to know is the South China Sea. I'm not going to have you learn the different ones in here, but I will have you learn the Gulf of Thailand right down in here. The Gulf of Thailand is off of the South China Sea, sitting over here off of the Thai Peninsula or the Malaysian Peninsula. They will argue about whose that is. And it's shallow water, huge squid, fisheries in there, shrimp, and other things like that come out of there as well. Good. Gulf of Thailand right in here. Move down towards Australia, and we've got the Great Barrier Reef right in over here. So this is the Coral Sea. And then to the south is the Tasman Sea down in here. Let me scroll out and see. Okay, so the Coral Sea right off in here where the Great Barrier Reef is. That's one you need to know. And then the Tasman Sea to the south, separating New Zealand from Australia and named after the island of Tasmania right over in here. Tasmania is really a part of Australia that was joined during the Ice Age when the ocean level was 300 feet lower. But since the Ice Age ended 15,000 years ago, this ocean level rose and separated it. So Tasmania, really wonderful place, lots of national parks and nature reserves, and really interesting place as well. The Tasman Sea right off of it. You need to know that one. Tasman Sea here, Coral Sea here, Indian Ocean here. And now let's move over into this region here, Africa, the Arabian Peninsula, Southern Europe. Let's go. I'm not going to have you do the Andaman Sea or the Bay of Bengal. The Arabian Sea off the west coast of India is an important one to know. And then the Persian Gulf right up in here. So the Persian Gulf. So what you have is you have Africa, and then you have the Red Sea, which is the East Asian Rift right in here, opening up and separating. This is where it's actually pulling apart, similar to North America and South America 200 million years ago, being ripped apart here, and this is the Red Sea right in here. On the other side of the Arabian Peninsula, you have the Persian Gulf. So let's look at where those are. So right in here, you have you have the Arabian Sea, the Persian Gulf, and then the Red Sea right here. Arabian Sea, Persian Gulf, Red Sea right there. Above that, you have the Mediterranean right in here. Mediterranean separates North Africa from Southern Europe and includes many islands in here, and the Italian peninsula, the Greek islands, etc., etc. Kind of dot the Mediterranean, a really famous body of water. Let's take a look at the Mediterranean here. So the Mediterranean sits right in here, Mediterranean Sea. And then up to the right of the Mediterranean, the two kind of inland seas that you can see on most of these maps is the Black Sea and then the Caspian Sea just to the right of it. And a good way to remember, why isn't that showing up? A good way to remember them is B, C. They go alphabetically. Black Sea, Caspian Sea. Black Sea, Caspian Sea that doesn't want to have its name pop up. Ooh, interesting. Black Sea right here, Caspian Sea right here, Mediterranean Sea right in here. And the Mediterranean is not technically, well, it wasn't technically connected to the Red Sea until a canal was dug, the Suez Canal, running right through Egypt, contentious political place. And now that has opened up shipping so you could come right in through here, through the Arabian Sea, connect up to the Red Sea, and drive right into the Mediterranean through the Suez Canal. The Mediterranean does open up in between Spain and Africa here through a natural strait. And that strait is called the Strait of Gibraltar, right in here. So the Strait of Gibraltar is the natural opening between Spain and Africa. This is literally how far apart Europe is from Africa, right in here. They basically touch. So the Strait of Gibraltar is a narrow strait. I forget how many miles it is, but I want to say something like 50 or 70 miles. And that's an important point to know. Separating the Atlantic from the Mediterranean, the Strait of Gibraltar. Okay. There are other seas within the Mediterranean that I'm not going to have you learn. Okay. Although I should have had, I should have had you learn the Adriatic Sea in here, but I didn't. Separating Italy from Croatia, Montenegro, and Albania. There, they just showed up. Okay. Man, I know we're covering a lot of ground here, but this is important stuff you needs to know. Let's take an outward view here. So we've got the Indian Ocean, the Arabian Sea, Persian Gulf, Red Sea, Mediterranean, Black Sea, Caspian Sea, Strait of Gibraltar, and now we're going to move up off to the western side of Europe and take a look at all the waters that surround there. So the ones I need you to know here. Here is Europe, north of the Mediterranean. Here's France and England, Norway, Denmark, Germany, the Netherlands. And in between all of that is a really shallow area of water. During the Ice Age, all of this was connected again, but now it is flooded, and this is called the North Sea. The North Sea on your map. The North Sea is right here. Here are the British Isles, okay? England and Ireland, and then the North Sea right there. North Sea. Anybody know what this island is right here? It's been in the news lately. Been a great volcano erupting there. Mark it if you don't. This is Greenland. This right here is Iceland. So the North Sea, right there, separating England from the rest of Europe. To the right of the North Sea is a more landlocked, sort of self-contained sea, and it is called the Baltic Sea. Baltic Sea sits off of what are collectively known as the Balkans: Estonia, Latvia, Lithuania, even Poland can be considered in that. What is this? And Germany, Denmark, and then, of course, Sweden and Finland to the north of it. The Baltic Sea is, the Vikings' old stomping ground, not the football team, but the actual Vikings. Used to sail through here and raid to the east, things like that. This is the Baltic Sea up in here. Collectively, this is known as the Balkans in this area here. Its own unique cultural unit. And really, in this area, we include Norway and Sweden and Finland in that umbrella of Scandinavia. Sweden and Norway share a lot culturally, more than they do with Finland. Finland is more language and culture, more tied to the Balkans over in here than it would be really to Sweden over here. Okay. To the north. So North Sea, Baltic Sea. This body of water north of Iceland, this is collectively called the Barents Sea. I think of it as barren, but it's Barents Sea. A cold, cold place. So here's the Barents Sea up in here. I guess it'd be the Norwegian Sea right off of Iceland. Just north of Sweden, Finland, the Barents Sea up in here. And I need you to know that one. That is on the list as well. The other ones are not, so I didn't put the Norwegian Sea or the Greenland Sea. Norwegian Sea, Greenland Sea. Barents Sea right up in here. And then the Arctic Ocean, again to the north of that. Let's take a look at that just from another perspective. So here's the Barents Sea in here, the Arctic Ocean, and then East Siberian Sea, Chukchi Sea, Beaufort Sea. See how I flipped it upside down here now? Kind of interesting, huh? Because we've circled all the way around to it. Here's Alaska. Here's Russia. There's the Aleutians down in there. The Bering Sea, Chukchi Sea, Sea of Okhotsk, Sea of Japan over in here now, Kamchatka Peninsula, different perspective. Hudson Bay up in here, and then the Great Lakes. Okay, I think we have covered the European side of things. Let's go back over to here. South of Greenland is the Labrador Sea. I didn't put that on our list, although that is a really important one off of Canada, the Labrador Sea. All of these are important. I got to pick my poisons. Off back to North America. We started in the Gulf of Alaska and worked our way around. Let's come back here. So we're here in Tillamook. The Gulf of Alaska is to the north of us, but if we cruise down south to California, we've got the Baja Peninsula. Baja is an extension of California. And there's a big fault line that runs right through here that cuts through California, connecting here all the way through, called the San Andreas. And that underscores and runs right underneath, right here, the Gulf of California, creating kind of a deep trench right there, separating Baja, Mexico from mainland Sonora, Mexico in here. So Gulf of California right in here, otherwise known as the Sea of Cortez historically. Gray whales migrate down our coast and calve here in the winter and then migrate back north in the spring up to Alaska and the Bering Sea where they feed. Gulf of California. If we shoot across, we've got the Gulf of Mexico in here, and you can see that's one nice big basin. The southern United States and then eastern Mexico and the Yucatan Peninsula along with Cuba sort of border this. And you can see really here how the Gulf of Mexico is its own basin compared to the Caribbean Sea. The Caribbean Sea is a separate basin. Geologically, it's got its own marine basin and weather patterns and circulations. Sometimes when you look at this map, it's hard to see them as two totally different, although now you can see Gulf of Mexico, Caribbean Sea in here. It's not just the islands that sort of make a fake line. It's actually a lot of underwater geography. One basin, two basins, the Caribbean down in here. Central America, right in here, separating the Caribbean from the Pacific and the Atlantic. And then, I think just one last one. But an important passage. There's a passage right in here that separates South America from Antarctica. You can see where Africa has been ripped and dragged away from all of this. Pangea has left much evidence scattered across the ocean floor, such as these old skid marks, drag marks, would be a better word. But there's a narrow passage right in through here where the ocean currents rip and the waves get huge. The largest waves and swells ever recorded have been recorded here. This is the dreaded Drake Passage. Drake Passage right through here. So write that down, Drake Passage on your paper right there. Okay, have we covered them all? I think so. Looking at the list here, I'm just going through it here. Sea of Okhotsk, Red Sea, Persian Gulf, Black Sea, Caspian. I think I might have added a few in there. You're welcome. East Siberian Sea, South China Sea, Yellow Sea, Weddell Sea, Weddell Seal. Okay. I didn't do the Ross Sea or the Weddell Sea, so let's do those. Those are off of Antarctica down in here. Let's jump on in and see. Get it? See? Oh, I'm funny, aren't I? Is it not going to give them to me here? It's not wanting to play. Let's go to Google Maps. Google Earth, Google Maps. What's the difference? I don't know if I can answer that question. Google Earth, Google Maps. Yeah, that's what I meant. Okay, let's take a look here. Antarctica. So the Weddell Sea is going to be right off of here. This is the Weddell Sea. And then the Ross Sea is going to be in this little notch back over in here. And the Ross Sea is more or less facing up right into the Indian Ocean, I believe. Is it? Oh, into the Pacific. And then the Weddell Sea is facing into the Atlantic Ocean as well there. Just put some arrows down in here. So this would be the Weddell Sea here, and then the Ross Sea over in here to the south. Honestly, don't know why I added those. I should probably just take those off and add some different ones. But those are important ones because if you go into the field in marine biology, there is a lot of work down around Antarctica and in the Southern Ocean. Because a lot of fisheries are there and because so much of our current issues with the Earth's climate changing rapidly, the issues are unfolding down there and a lot of the research is down there as well. So there's a lot of opportunity for work and research in that area, so you should be familiar with that. Weddell Sea, Ross Sea, right off the butts of Antarctica there. Looks like a butt. Okay, work on that. Label them, make it look good. You can use, one of the sheet that maybe you marked up for this particular activity as your scratch paper, and then do a second one. Make it look nice. And not only do you have to do this, you have to learn where these are. So we're going to practice this in class, and I will point to things, and then have you go, oh yeah, that's this, that's that, and we'll practice. And you'll learn these, and you'll get good at these. And it's one of the things you can walk away from this class and actually kind of hang on to for the rest of your life, hopefully. A little bit of knowledge about what is up with planet Earth or planet Ocean. Okay, everybody, thanks for stopping and shopping. Get this done, work on this now, and make it look good. And then practice. Bye.